live, hopefully. Let me just wait for Twitch to catch up. I think so far so good. Okay, so this week we are doing the interpreter pattern, but just to do a quick recap, we have started the whole process over again, and we've got a new project. Last time we were doing the MudZ project, which is still out there. It's alive and well. But for the sake of this experiment of trying to be able to do a design patterns course, so then we got to a place where it was just a good time to begin anew. So we got the Storybox, and try and implement a lot of good things this time around as far as best practices. Got a lot of help out there in the community. Smudge, Rob, a few others, constantly giving suggestions, and I'm learning every day. I have a wiki page on the project that I am trying to keep up to date. So hopefully with every new project, there's going to be a refinement to this kind of the presentation and this process and how we go about doing things. So if you come to the wiki and you go to the first semester, I'm going to try to do a much better job of outlining not only where the code is for that week and that pattern, but also the video on YouTube of this session, and then all the resources, so the pattern details, the kata that we're basing it off of, and then whatever else we use. So last time we had a great suggestion from Smudge to modernize the solution architecture, and he was kind enough to do that in a pull request. I've since merged that in, and a link to the guidance for that is here. So constantly trying to make those things happen. Some of the vocab that we either got to or will get to in refactors. So that brings us to the interpreter pattern. And I'm going to go ahead and clone this guy anew. So, Storybox, what is it? I've also got this little brainstorm place, right? Doesn't quite make it to the wiki yet, but I'm just kind of writing down ideas. So it's an interactive fiction engine. Totally just an example of how to approach this, not trying to replace any of the established formats or clients that are out there, but just paying an homage. So there's Planetfall, there's Galatea, Hitchhiker's Guide. Those are three of the, I think, pretty big and popular ones that kind of crossed over to mainstream, for whatever that's worth. There's also a documentary out there called Get Lamp. I was going to say, for a really geeky deep dive, see the documentary. I'm going to say Get Lamp. I'm going to find that. So this is really a just a really good documentary on text-based adventures. So if you ever wanted to really dig in and see where all this is kind of drawing its inspiration from, there it is. So I'm going to try to keep it really basic and hopefully serve as a better example, trying to get better every time, about how to run through, let me jump back over to the wiki, what's going to be about 10 design patterns, 10 kind of go-to ways to architect a project kind of reliably every time. So that's the goal, maybe the stretch goal. So I'm going to come back over here, I'm going to open from source control. I'm going to clone. I'm going to go ahead, oops, not that. I want this. I'm going to go ahead and clone this guy. I'm going to double click to open it. Then in the solutions, I'm going to double click this guy. Okay, so come back over to solution, now it's loaded. already seeing the benefits of the new structure. Things look good, they feel good. Okay, so I'm going to go ahead and make my console project my startup. And I'll open up Program so we can see what we did. So that's what we got, the factory pattern. You go back to that video for all the ins and outs, but essentially we said we have a game library and we want to give the user the ability to load a game. So this is a perfect candidate for the creational pattern of factory, right? So we want to be able to take it an input and then go into some sort of decision logic that then loads the game they chose. So if we go into our core and our game factory, right now we've got a pretty simple switch statement. Nothing too crazy here. We do want to, at some point, refactor this to show ways of avoiding switch statements because they can become very, very unwieldy. One of the things that I have a tendency to do is inside of this space, like right now I'm just returning the new game with a name. But if I said var game is now equal to new sin, and I return the game down here, the fear is that in this space, do lots of stuff, right? And so I have a game library of like 20 games, and I have every game has this very particular way that it's instantiated, right, or how it's built. This becomes a very unwieldy factory. So there's better ways of organizing this very simple pattern that'll kind of save us from ourselves. And I kind of want to get into that, maybe not tonight, but certainly in the future. And it naturally goes into the builder pattern, right? So having a way to build objects that's consistent, reliable, and also extensible. So, and I'm going to check chat in 1 minute. It's my cookie jar. So at the end, so the factory pattern is actually very simple. But then at the end of that kata, we got to a point where we're taking in input from the user, from the client. And we need to be able to transform that input into something that our engine or our business logic knows how to deal with. So I think the word that comes to mind is we need to interpret, right? We need to interpret that input into something. Because we don't want to name what that something is yet, but into something, right? Something strongly typed, preferably, but it could be anything. Ooh. I got to check chat. Hang on. Smudge in chat asked if I had a chance to look at the advanced branch. I'll show that here. There's a pull request out there, and it's actually a really, really awesome idea. The advanced solution. And if anybody's curious, they can come here and take a look at it. And I really like it. I really like it because it offers the ability for 2 tracks. Because what I'm doing here is pretty straightforward as far as your academic learnings. Right, like you're not going to find anything here that's really going to blow your mind too much. It's pretty linear. When you start getting into like your composition, your managed sensibility frameworks, your IOC containers, all of your real kind of top dollar ways to keep things clean and solid. It seems like that's what the advanced branch could definitely provide. And correct me if I'm wrong, Smudge, but it's super cool. And so part of my homework is to devote more time to GitHub and more time to just the development process. And so I really hope to give that the time it deserves and get that integrated. But we are kind of winging it. Cool. And I know within that kind of idea of composition, it really does change the way you'd approach even this small bit of code. Okay. So I'm interpreting the what's coming in. And as I've said before, at least in my own humble opinion, that even the smallest algorithm is still an algorithm. So anything that, that churns on something, produces something else, is going to be an algorithm. And so here we have what is really kind of a lot. Like, it doesn't look like a lot, but it really, if you break it down, it's a lot because of the number of things that can go wrong. So I'm casting here. I'm casting on a parse of a string that could be anything. And the places for that to blow up are numerous. So this is the easy one, right? This is not a number. Boom. This casts to something in the game, and it tries to cast to something that doesn't exist in our game library. Also blows up. How do we check to ensure what we have back is what we want? It could be a happy accident, right? So we definitely want to wrap this with some assurances. That's where the interpreter pattern comes in. So let's look at the interpreter pattern. And I really just try to run out on the internet and grab the first link that I see. And see lots of them turning purple here, but let's click on this one. Because there's so many takes on how this pattern should be implemented. And I want to definitely show that whatever I have in my kata or whatever I go as a go-to is what I'm most comfortable with. The most important thing is that the spirit of the pattern is upheld and we understand what problem we're trying to solve. Ooh, alright, so I do like this one. I do. But you can just see by the UML diagram that even the representation for these two feels very different. So let me go ahead and open up this, open up this, open up this. Alright? So if your brain works better with this kind of visual aid, then I say use this. Right? It works better with this, which is incidentally the same as we see here. This is the one I like. I'm not saying it's the best, but it's what makes sense to me. So, when we're doing the interpreter pattern, I think the definition is pretty straightforward. Giving a language, define a representation for its grammar, along with an interpreter that uses representation to interpret sentences in the language. That is super fancy words for a concept that I think we can show pretty clearly. So, assuming that I have a known structure, right? So we'll just say that I've got input that has to conform. That has to conform to part A, part B. And so this is just, and part A and part B have to be strongly typed. So they have to be tied to something very specific. So we've got this language that we're dealing with. So any statement in our language, any sentence, is going to be composed just of part A and part B. So if we know there can only be two parts, then we consider this to be a terminal expression, meaning that it's got a known and defined end every time. If our input instead looks something like a part A just say plus part B or minus part C, right? So if it can be continuous in this representation, so a statement that comes in can be very long, and we don't necessarily know where the end is going to occur until we've processed all of it, then we're calling that a non-terminal expression. So for the sake of our problem, and probably most interpreting problems that you're going to run into, you're probably going to see terminal expressions. Without getting into things like expression trees and all kinds of funniness that come with a non-terminal expression. So we're going to be doing a terminal expression. Okay. So what is our interpretive pattern going to consist of? So we've got a abstract expression, which we see here, which is what we're going to be considering our API. We're going to be calling against this abstract expression. And then we're just going to have a terminal expression, a client and a context. So our context for right now is going to be our application. So we kind of have that, we kind of cheat there a little bit, but we haven't gotten to week 3, which is the context object pattern. So the actual application domain is going to be our context, the area in which we operate. And for our client, right now our client is game name. It's this var, right? And we assume this to come in as a string, more than likely. So right now, this is our client. And we can probably improve on that. So, let's make some classes. Let's make a new client, something that's a little smarter than just a string variable. Let's make a an abstract expression. We'll start there. We're going to go to common again. I'm just going to go ahead and just going to open a folder called Interpreter. I'm going to add a new class. Ooh, I get to check chat. I'm going to check chat in like 3 minutes. Alright. So I'm just going to, this is going to be my abstract expression. I'm just going to call it expression. So just go ahead and look straight at the documentation and see what that should entail. So you can see that, I don't know how easy this is. Let's go ahead and blow this up a little bit. Alright, so the only function inside the abstract expression will take in the context it's going to interpret. And it really makes no qualms about what kind of output we're going to get or what those instructions should entail. So let's come back over to our expression. Let me move this back down. Okay. So as you can see here, they're choosing to return back void and take in a context. So I'm going to return back. We'll do void. We'll do void. Yeah, let's do void to start off. So now our context right now, we're going to take in. We're just going to have the string, because everything inside of our application is done in strings. Oops. So that's it. That's our expression. Super simple. Now, where this gets fun, where we're actually going to be using a pretty straightforward pattern to do some really fun stuff, is depending on where we are in our game or our story, is going to depend what kind of interpreter we want to use. So right now, please type the game you want to play. What's going to be, the game selection interpreter. Still terminal, right? Still a terminal expression. But it's going to be one interpreter. And then when we load the game and we're taking in commands to navigate the story, we want a command interpreter. So we're going to have a few different interpreters depending on where we are. And how we handle that's really a subject for later patterns. But we can already start to see where decoupling this interpretation of input is really beneficial. Because otherwise we'd have this long spaghetti code of if, this, else kind of logic. And we don't want that. Alright, so we have an expression. So, we'll come back over to this guy. And this code example is pretty uninspired, but it gets the job done. So they just have a terminal expression and a non-terminal expression, which is fine. So we're going to go ahead and create our own expression interpreter. And we're just going to call it game selection. So we do a public class game selection interpreter, and then we're going to inherit from expression. Oop, I'm going to check chat real fast to see my name in black. Oh, I see Dan G in chat. Hello, Dan G. Glad you could make it. And then, of course, any other lurkers. So, now that we've got this interpreter, I can implement the missing members, which is just interpret. So pretty straightforward. And then once we have a game loaded and we have a way to switch over to the other interpreter, then we're going to go ahead and write that. But we don't really have that need yet. Okay, so when I'm taking my string context, coming over from program, this guy, right, for as poor as it is currently what we need. Okay, so inside of this, it's going to be context. Oh, I'll hold the phone. I might need to pull game library up into my common. Or do I want to bring interpreter down to my core? Alright, so we're going to go ahead and leave expression up in the common. We're going to go ahead and bring the interpreter down in the core. I think that makes sense. Go ahead and add a new folder. Interpreter. I'm going to misspell interpreter. Like I can promise that right now. I don't know when it's going to happen, but it's going to happen. Let's go ahead and bring that down. We'll go ahead and delete that guy. Oops. Okay. So, it's a pretty, let's say this, var game lib, called item. So, it's still an ugly algorithm, but it is an algorithm, and now it's inside of our interpreter, which is satisfying our expression. So, can get rid of this guy and we can replace it with the interpreter itself. It's going to look ugly for a second. New core.domain. Oops. Let's go ahead and move this namespace. So now we have our interpreter. What we want to do is we want to say interpreter dot interpret game name. Alright, so this guy is void. So what does that mean? It means that we need to have a way to get what this is interpreted. This is going to be, unfortunately, where a lot of the examples online are going to fall short on you. Everything wants to be super simple. That's all fine, but everything kind of cheats, right? And they all do, like, when push comes to shove, they all console write line or output their stuff. So we can do this for right now, where we say that every expression returns a string or a game library object. Then that might not be the case. Give me a second. I don't necessarily know if I want to introduce things I know I'm going to undo or redo later on. Because we are going to have multiple interpreters. And they're probably going to interpret things that are not always going to be a game library item. But I think actually we're going to be safe. We might be safe with an int. But do I want to create a context object right now? Let's do it. Let's create a context. We're jumping the gun a little bit, but it's got to go somewhere. So, let's explore that just for a second. Class game context. Okay, so I think we're safe, but we're going to explore it together, right? Because what do we know we're always going to need? We know that we're going to need a and I keep putting these things in common, like that's where they're going to go. When all my stuff is in core. So I'm going to change these namespaces around. Okay, so I know that my context forever and all time, once the game starts, I know that I'm going to have a game. We'll say that's the game library item. And going forward, I'm probably going to have a command. I'm probably going to have the actual game itself, right? So I'm also going to have just iGame. Let's just say I'm also going to have a string player name. Let's call it string player. So this is going to be my game context. So this is good. So I don't think we're going too far into the pattern that we're going to try to get into next week. So it shouldn't be confusing. But it does make things a whole lot easier now. So I can come back over here and I can still make this void. And when I take in my context, I can say that I actually want a real deal game context. Man, this feels better already. And this frees me up Wait a minute. I think my IntelliSense is going all wackadoodle on me. Alright, so what this frees me up to do... Wait. Oh. Alright, I need to check that here in a second. It hates me. And it shouldn't, right? Can you see that? But I probably... Oh, look at that. I got game object defined in two different places. Man. Okay. Why are you mad? Super small brain fart, because I think my IntelliSense is going all silly on me for some things. Yeah. Anywho. So when I pass in this context, I'm going to be parsing the input. So I need to also have my user input. Just say that. What the? Hold on, folks. Hold on. I found the culprit. I've done confused myself. So we've got this common project, which we have so that we can share contracts and such amongst different tiers of our application. But that comes with the consequence of really having to be careful where we stick things. So it makes us answer the question of what should be where. So I'm just going to tidy that up. So here's our interface for the game context. It's now in our common. And then our implementation of that interface is going to be inside of our core. And we're going to move our types. All of our types and such are going to go up into common. And then instead of our class, make that public. All this stuff will be public and public. Cool. Hope that didn't get too confusing. I certainly confused myself. ourselves around here, fix all of this. We're going to change the signature from game context to iGame context. We're going to change this guy to iGame context so that it satisfies the contract. And we are back into a happy place. So, long story short, now, whatever interpreter I create is going to be doing something to work with or populate the game or the game context, and that's what I'm going to be passing around to all aspects of my game, and it'll be in charge of keeping track of what's been done, where I am in the story, who the current player is, what the current command is, etc., etc. And it's going to build a lot of heft into this guy. And we'll go into that more next week when we actually do the actual pattern itself, even though we did most of it just now. So, again, we're going to keep this really ugly algorithm because it's still an algorithm, right? It hasn't failed us yet, so we don't want to introduce complexity before we're ready. So we're just going to say that the context dot game library item is going to be the result of this algorithm. So you can already see that we've isolated all of this noise, right? All this complexity. Whatever this ends up being is now nicely tucked away inside of this interpret function. So we're now free to make it as crazy as we want, as safe as we want, wrap it in as many try-catches as we need to ensure that it fires without a hitch. Or if it malfunctions, it does so safely. And we also have the expression that we can build more interpreters off of. And now what we need is we need to instantiate our context. So if I just say var context is equal to new game context, now I've got something that I'm able to populate. So I can say that now there's still, your brain can start to churn a bit in terms of where our other patterns are going to come in. Because here, we're going to say that context dot user input is equal to console dot readline. And then we just magically know that we want the game selection interpreter. But in the future, we really want to do a smarter way to know what interpreter to use. And then we're going to interpret that user input. But I just want the context. And let's just go ahead and make sure this thing conforms to the iGame context contract, the interface. Okay, so presumably once I've dumped my context into my interpreter, I should now have a game library item. Right? Voila. So, yes, I introduced the context a little bit early, but I think that's been really good. So we've got this interpreter, and we know we have something to chew on. We're like, how do we make the selection criteria smarter? Because just like in our last project, when we have our console, our command prompt, we're gonna have it on a loop. So every time you type in something, it's going to put what you typed into the user input. It's going to decide what interpreter to pass that into in order to populate the game context. And then it's going to send that game context off to who knows what to satisfy your needs. In our case, we know that we need to send it off to the game factory to fetch the game. But this might not always be the next step, right? The next step might be, okay, interpret, and then, apply to the game or execute against the game. It might be nothing related to the game. It might be a help command, right? And so you might have to interpret this context or this state, right? We have to evaluate, I guess is the better way of saying. If we evaluate the state that we're in and we load our interpreter based off of that, then we know where to go as well. We can say, okay, we're currently in a command state. So everything we come into the command interpreter. But I'm getting well ahead of it. So I am trying to keep things down to 45 minutes this semester. And I think we nailed it. I really think we nailed it as far as getting the expression in there. The interpreter pattern has been wired up. So what happens when we just run this as it is? Oops. Instead of var game here, what I need to do is context.game is equal to the game factory. And for the last few minutes, let's just keep playing around with the look of this application. Interpreter as well. Let's assume that I'm going to need to have a public expression interpreter. So I'm filling up this kind of grab bag of tools. So I'm always going to know what interpreter I'm using. It might change, but it feels good in the moment. So let's get rid of that var and do context.interpreter is equal to this guy. This new game selection interpreter. Okay. We're not going to have a whole lot to talk about next week because I keep doing context object pattern stuff this week. All right? This was supposed to be the fun lesson learned. But we'll deep dive next time. We'll throw some sauce on it. I don't know if that means anything. Throw some sauce on it. Maybe. Throw some sauce on it. Okay. So, but this is definitely the idea, is that we want to be able to hinge everything around the context, and then we want to interpret. So, what happens when we run this thing in its current state? And if it breaks, then I'll say we'll do it next week, since we kind of threw some things in that we weren't supposed to. Kind of like a little bit like Christmas. So, I create a new context. I write some stuff out to the console. I say, what game do you want to play? Now, we don't have a menu or anything, right? And we don't have anything around this interpreter that can really give us a good, responsive prompt. So if we do anything bad here, it's just going to crash. But let's just say we do that. And so we have our user input, which is the string 1. And then we're creating our new interpreter. I'm going to go ahead and F11 to go into that interpret function. And then that same ugly algorithm that isn't safe, that doesn't do any kind of checking, doesn't kind of do any kind of graceful failing, just takes that input and parses it to an int, and then casts that int to the game library type. So, what's fun here? Oh, sorry. And then I set my game as whatever comes back out of this game factory when I pass it in this type. And then I write out to the console, you chose blank game. So you chose bubble command for the last bubble. So, pretty fun stuff. And that's it. That's all we wanted to do. We accomplished that. What we're missing now is the ability to branch this the way that we need to add some complexity the way that we want to. We're going to try to avoid turning this space into anything uglier than it needs to be. So as soon as we hit that wall, we're going to implement a pattern that allows us to branch more complexity. But the overall scope of this project should be much less than what we saw in MUD-Z, which I'm hoping really gives us the chance to both really explore the best practices, the sophomore craftsmanship. The patterns themselves should be very clearly exposed inside the architecture. And then when folks like Smudge go above and beyond and really add stuff to the advanced branch, you should be able to also see very clearly the basic versus the advanced approach, because we're not going to have too much noise there to get in the way. Okay. So what do I have here? So one other thing, you'll notice that I'm not returning the context, right? But I am retaining the values that I change inside the functions. This is it's kind of it'll bend your brain, I think, the first time you think about it, but changes that because I'm within my application domain, I think it's the simplest way that I can explain it, because I only understand things in simple terms. But because I'm inside of this domain, I can throw the context into a method, and if I change it inside of that method, I'll be changing my context within this scope. So I don't need to, for example, inside of my expression, you'd expect me to return back, or maybe you won't. Maybe you're smarter than I was 3 years ago or whatever it was. But you'll often see people returning back context here. They'll say, oh, I take in the game context, I manipulate it, and then I return it back. There's no need. If you've maintained your scope properly, you can get around so much noise inside of your application that is completely unnecessary, right? So it's really important to understand when things are being passed by value and by reference, right? And we see that in things like the flyweight pattern, when we're actually being able to reuse objects efficiently. Part of that efficient reuse of objects is understanding what's available to you in what scope, so you don't have needless casts, needless new ups, and needless whatever. So I'm going to go ahead and commit this guy, hang around and chat for a few seconds, and I really hope that we've hit that sweet spot of really got in there, explored the pattern, made it very clear in the code, but also made the video very accessible and watchable to anybody who's going to come in tomorrow or the next day and look through it. Alright, I'm looking at you, Smudge, when I say this. I've got no untracked files. I am the worst at that. Interpreter pattern. So this is going to be our commit. Come back over here. And I'll be on my best behavior as far as GitHub is concerned, and I'll update the wiki. I'll convert the video so it's available on YouTube, and I'll make sure that all these links are up to date. So cool. And I'll really look, and I'll find an example, like a website, that I really like and I really, really want to share, and I'll throw that up here in these links. Alright, I'm going to catch up on chat as I shut things down, and then I'll give one last wave to thank everybody for hanging out, but I think it's been a good session. I'll see you guys next week. Alright, that's it. I'm going to hang out in chat for a few more minutes, but thanks Rob, thanks Danjeet, thanks so much for hanging out, and thanks to anybody that's been lurking, and I'll see you guys next week.